Here we are switching to some inverse trig, which sounds way more complicated than it is. The only difference on inverse trig is you're going to be using the second button on your calculator a little bit. But other than that, we're going to be solving for two unknown angles while we have two known sides. So again, we have two known values and three missing values, just like the other way, but instead one of them was an angle before, now one of them is a side, and so is the other. So we'll go ahead and start with the 16 inches and the 23 inches here, and we have our unknown as B. Now we can really do this a number of ways. It just depends if we want to look for one of our angles here first, or if we want to use the Pythagorean theorem to just solve for the missing side. So let's start off with the easy one first. We'll go ahead and just solve for the missing side. So if we take our hypotenuse as 23, that's going to be our C value, and our A 16 squared plus B squared will equal our C 23 squared. So if we want to move that around a little bit first, we could say that we'll just subtract 16 squared from this side and subtract it from this side. Those will cancel out. We'll have B squared equals 23 squared minus 16 squared. We're doing this in a little bit different order, but we're not changing any of the rules around. I'm going to square both sides. This cancels out, so now we just have B equals the square root of 23 squared minus 16 squared. So we didn't even put that whole thing in our calculator and do it in one step. So square root of 23 squared minus 16 squared, and make sure to close your parentheses if you're using the scientific calculator. And that's going to give you B equals 16.523 inches. So B is 16.523 inches. And now we're going to use a little bit of our inverse trig to solve for the remaining values. So depending on what perspective you want to have, you're going to use that 16 and the 23 differently. So if we want to use B as our perspective, like we talked about doing earlier, we're going to say that we're going to be looking at, from B, the opposite and the hypotenuse. So opposite and hypotenuse, I know that's sine. So sine of B equals opposite 16 over hypotenuse 23. And again, our variable this time is B, so that's the thing we want to get by itself. So what we're going to do is the opposite to both sides. We're going to take the inverse sine inverse, and the inverse sine of the other side cancel out. So B is going to equal the inverse sine of 16 over 23. So if you use the second feature on your calculator and hit sine, you're going to have inverse sine. You can just type that fraction directly into there, 16 divided by 23. And that's going to give you an angle of 44.079. So B is 44.079 degrees. Now we're going to solve this for theta two different ways. One, so we can get the value, and the second time so we can check our work. So the first way we're going to use is just the same exact perspective here that we had on the other value. Well, now since we're solving for theta, we're going to use that as our perspective, and we're going to go ahead and ignore B for now. So now that we're solving for theta, and we know the value that is adjacent to it and the hypotenuse, we're going to go say that adjacent and hypotenuse, A and H, that's going to be my cosine. So cosine of theta equals adjacent, which is 16 over hypotenuse, 23. very similar to what we did last time, but before we were using sine, now we're using cosine. Now we can use the same thing. We'll go ahead and get rid of this and just change it to inverse cosine 16 over 23. And that gives us theta equals 45.921. So if we want to verify our work, we can use our 180-degree triangle rule. And we know that this angle is 90, B is 44.079, and theta is 45.921. So all of those should add up to 180. So 90 degrees plus 44.079 plus 45.921 gives us exactly 180 degrees. So again, we added this and this to this, and that gave us our total of 180, so our work checked out. So inverse trig, same thing, but now we're just using inverse sine, cosine, and tangent instead of regular sine, cosine, and tangent. And again, the only time you would use that is when you have two sides instead of a side and an angle. All right, we'll do a couple more. You guys should be on track.